Do you know what happens to a home appliance when it doesn't work anymore and reaches its end of life? Citizens have several ways to dispose of it. From the waste collection facility, our object is transported to a treatment plant. There, the item is separated into pieces and valuable fractions are collected. In the treatment facility, first of all, the operators manually separate the dangerous components, such as batteries and motors. Then, the combination of grinders, shredders, and magnets is used to separate the different fractions, such as copper, iron, aluminum, and plastics. And so, finally, plastics, metals, and other fractions are collected separately. Nowadays, metals are totally recycled. But what happens to plastics? Only a low percentage of plastic is recycled. In fact, today, few recycling technologies are available for plastics, and the challenge is represented by those plastics which contain hazardous substances. NONTOX project was born to solve the problem of this kind of recycling. NONTOX is focused on a system of innovative solutions which target plastics waste coming from WEEE, waste electrical and electronic equipment, C&DW, construction and demolition waste, and ELV, end-of-life vehicles. Let's consider now only those plastics containing hazardous substances, which are the focus of NONTOX project. In order to reduce the content of the hazardous substances fostering the recycle, plastics can undergo different processes: creosolve, extra clean, MODX, and the thermochemical conversion. Let's know more about each of them.
The creosolve process has been developed as a solvent-based plastic recycling approach that applies whenever current recycling methods fail. For example, that might be the case when mixed, dark, or composite plastics affect optical sorting. In case that plastic waste contains legacy additives, like earlier applied brominated flame retardants, it is the high purification potential of the creosolve process that enables a more than 99% removal of such compounds for matrix polymer. And that enables the recycled polymer entering a second life in compliance with strict European regulations.
Extruclean process is carried out in a plant. We are located in Valencia, in Spain. Extruclean is a mechanical recycling technology based on extrusion with simultaneous extractions by supercritical CO2. Hazardous substances are volatilized and extracted from the polymer melted during the extrusion by degassing with a vacuum pump. The removed substances are absorbed in activated carbon filters and are safely disposed by a hazardous waste management company.
The main result of these two processes is recycled polymer provided in pellets. The non-target plastics and residues from the previous processes are sent to the thermochemical conversion.
Indea Energy is developing a thermochemical process to convert non-target plastic and residues from creosol and extruclean into halogen-free hydrocarbons. Those hydrocarbons are useful for fuel components, industrial solvents, or as a petrochemical feedstocks. This process combines thermal and catalytic steps and also produce char and gas that can be used to produce the energy required by the process.
Another interesting process is performed by the MODX extruder. MODX extruder will be used to pre-treat and compact selected waste feedstock with different shape, density, and size ratios. Moreover, in connection with the main recycling processes already described, thermal decomposition of hazardous additives such as brominated flame retardants will be carefully investigated and developed using the modular extruder. The clean plastic coming from creosolve and extra clean processes, purified from hazardous substances, is stabilized and used for the production of new products.